All right. So today we're going to kind of change gears a little bit, okay, with what we're talking about, but it's not as much as you might think, okay? So we're going to talk about something called dimensional analysis, which is a very fancy word, okay, or a very fancy phrase. But what it really means, if you want to put in parentheses here, it really just means unit conversion, okay, which some of you already did a little bit today, right? We converted from inches to feet or feet to inches, right? Sometimes you just do it in your head. You're able to do it no problem. But sometimes it takes a little bit of work, okay? There's different ways to convert units too. I'm going to show you a strategy that's called, kind of like also called dimensional analysis, the strategy you can use to help, convert. And it has to do with the idea that you can kind of treat units, okay? You can treat units almost like that they're a variable or like a quantity, right? That can be canceled out and eliminated, just like you do with like fractions, okay? And I'll show you what I mean by that in just a second here. So, for example, and you can see here some conversions that are given to you, okay? I will get back to you on what conversions you'll kind of need to know, but from the looks of it here, you don't need to know many conversions. We'll be giving you those, okay? So you just need to know how to use them, all right? So, just a few here to go through. We have 1 pound, which is 16 ounces, and that's kind of an interesting conversion right there because ounces, so a pound, what does that measure about an object? It's what? Yeah? Weight, right. And so then converting that to ounces, this is also a measure of weight, like how much something weighs. However, if you ever look at like a drink, right, like a can of soda or something like that, what's that measured in? Ounces as well. So does that mean the can of soda is 12, well I think it's normally like what, a can of soda is 12 ounces, right? I think it is. So can of soda is 12 ounces. Does that mean it's almost a pound? Well, not really, because we also have this other kind of ounce that's a measure of volume, okay? So you have ounces right here. This is confusing, but ounces can be converted to a weight, right, which is how heavy something is. But then ounces can also refer to a volume, how much space it takes up, right? And how heavy something is and how much space it takes up, they're related, but are they the same? Not necessarily, right? Not necessarily, right? So volume and weight aren't necessarily the same thing, but yet we have this word ounce that can measure both things. So keep an eye out for that. If you're ever at like the grocery store or something, if you buy like snacks or if you buy like chips or cereal, for example, you ever open up a bag of chips and like half of it's air? Yeah, right? Okay. So what they will say, the manufacturers, they'll say, well, we're not selling it by volume. So you open it up and you're like, whoa, there's only half a bag of chips here, kind of thing. They sell it by weight. So you'll see it says like, however many ounces, but that's an ounces by weight. Whereas your soda, that's like ounces by volume and stuff like that. So that's kind of weird. Anyway, we see some other conversions here. A fathom, okay, so that's a unit of measuring. Normally you see that in like nautical stuff, on the sea or on the water or something. But there's 1 foot equals 12 inches, which you already used earlier in the warm-up. 1 year is 365 days. And really that's an estimate, right? That's an approximation, right? Because that's what we have.
They grew up with the nuns, and let me tell you, 1 year is 364 and 1/4 days.
Yeah, there you go. Exactly right. So we had
get the answer wrong.
The leap year and stuff. Yeah.
Why doesn't the rest of the world just use the imperial system?
That's a good question.
I saw that movie. That's why I was like,
I don't know, but I want to believe it has. Why don't? So wait, you're saying why doesn't the rest of the world why don't we use the metric system, or why doesn't everyone else use inches and feet and stuff like that?
I think the rest of the world should use inches and feet.
You really think so? Interesting.
Yes.
What's your argument for that?
All right, here's my argument. So, we may be the only country on Earth that uses
No,
the.
there's a country in the Middle East.
We're America, we are that country. All right. It might be the only country that matters that uses the imperial system.
Okay.
But we're also the only country that made it to the moon.
true.
Wow.
So
And it takes
we
a lot of
did this.
So far.
It takes a lot of smarts to go to the moon.
That's true. That's true. Until someone else goes to the moon, and then we have a problem.
But here's the problem with that. You know what system the space people use? They're not using inches and feet.
AU.
Yeah.
You go,
Just the bull.
the scientific world uses the metric system though.
Ben, do you have something you want to say?
Wasn't a German scientist that made the rocket though?
Well, that helped. Yeah, they helped. They were the ones that
They
first
used the
did.
metric system?
They probably, yeah, they do. I'm sure. Catherine, did you have something you wanted to say? Okay. So I will say, I believe there's like a story that I've heard before too, Tyler, that was like, because we don't make all the pieces for the rockets here in the United States, and so the issue comes up too, where I think there were errors. There have been like accidents and things like that occurred because of conversions and not converting from metric to imperial and vice versa and stuff. So it's an important topic for sure, right? Because we want to make sure we're all talking about the same thing. And keep in mind too that some of these conversions, like whenever you're converting from like imperial to metric like this, these are rounded. Okay, these decimals probably go on for a very long time if you want to be very precise. Same thing here, meter and feet. 1 meter is not exactly 3.28 feet, but it's close, and 1 pound is not exactly 0.45 kilograms, but it's close, So if you guys go and this is helpful for those of you that are in like weightlifting, or you do sports or something like that, right? 1 pound is 0.45 kilograms, although for our purposes, you could also say 2.2 pounds is 1 kilogram. But of course, everything in the weight room is in pounds anyway, so you don't have to worry about converting from kilograms to pounds. But anyway, it's interesting. So these are just a few of the many kind of unit conversions we can utilize. But let's go ahead and get into some problems here and to see how we're going to do this. All right. So number one, Brian has a pet Komodo dragon that weighs 12 kilograms. How many pounds does his pet weigh? So what we're going to do is take this 12 kilogram quantity, which is a weight, right? And we're going to then convert that from kilograms into pounds. All right? And so what we want to do then is to eliminate this kilogram label. Okay? Well, in order to eliminate that kilogram label, I'm going to multiply by another fraction over here. Okay? And in order to cancel out kilograms, where do I need to have kilograms? In the numerator or the denominator? If I have kilograms in the numerator, where do I now need kilograms over here for it to cancel? In the denominator, right? Because then in the bottom, we'll have it cancel out. And I'm going to put 1 kilogram here. We're going to convert 1 kilogram. Okay. Or actually, well, okay, I guess I can do that because I gave you guys the 2.2 there. Okay. So 1 kilogram, and we want to convert that. So now the kilograms will cancel. Okay. And since we're shooting for pounds, what's the equivalent of 1 kilogram in pounds?
2.2.
All right, so we want to be careful here. 1 pound is 0.45 kilograms, but I've got 1 kilogram. What's 1 kilogram equal? That's this 2.2 right here. So you see the difference here. I couldn't use this one because I had 1 kilogram, and that's the same thing as 0.45. So I didn't have one. I have 1 kilogram. I want to convert that to pounds. Here it says what 1 pound is in number of kilograms, but I need 1 kilogram was how many pounds now. So there's that.
I'm sorry, what?
Yeah. I realize this is harder than I thought it was going to be. But the problem here, and I maybe made it harder by adding in this extra piece of information here, but it's still useful. So in summary here, we started with 12 kilograms. I put it over 1, just making a fraction here. We wanted the kilograms to cancel. We wanted to change out of kilograms. So we put another fraction over here, 1 kilogram and 2.2 pounds. So what we're multiplying by here is really like multiplying by 1, right? 2.2 pounds is the same as 1 kilogram. So we're multiplying by something that's really just a value of 1. Something that's the same as something else here. Okay? And now we have pounds, the unit we're interested in, and so we just multiply. 12 times 2.2 So what's 12 times 2.2? Well, that we can go to our calculator. Okay. So 12 times 2.2, 26.4. Okay. Since our kilograms canceled out, what's our new label? What's our new unit here? That didn't cancel out. Pounds, right? Okay, pounds. LBS.
But we could have done it without knowing the 2.2 pounds, just with the information up there.
Correct, yes.
Do we have to do it like that, or can we just do it on our calculators?
So you can just do it on your calculator. However, I will say we're going to get to some more difficult ones in the back, and you're going to want to also be familiar with doing it this way. But I understand what you're saying. It's a little confusing, but I get that. Okay, but Ms. Mulcahy's right. We didn't have to do it using the 2.2 pounds equals 1 kilogram. We could have instead still started with the 12 kilograms there over 1. Oops, not equals, times, and we could have used this one right here. In this case, we would put the 0.45 kilograms on the bottom and the 1 pound on top, like that. So that way the kilograms will still cancel. Okay, the kilograms will still cancel. Okay, and so to multiply our fractions, we just multiply our numerator. What's 12 times 1? 12. And then what's 1 times 0.45? Not a trick question. 1 times 0.45. What's that? 1 times 0.45 is just 0.45. Just. Oh, gotcha. Okay, 12 over 0.45. But now what can we do with this? Well, let's actually divide it here. What is 12 divided by 0.45? And what number have we better get? Better get 26.4. Ooh, and we get like 26.7. Why is that? Well, because probably my 2.2 there was not as exact as this 0.45. Okay? We get awfully close. So I'm going to say 26.7 there. Okay? So we get pretty close. But again, my 2.2 is not as precise as that 0.45 is, I think. That's why. Okay? Let's do another one, though. Let's try another one. Okay? Mark's 30th birthday is the end of this week. How many seconds would he be alive on this birthday? So the moment that his 30th birthday happens, how many seconds would that actually end up being? Right? We know how many years. Go ahead.
Is it 946,080,000?
946,080,000. Okay, well, let's find out. So we'll write that answer down. Okay. So 30 is a number of what? If it's your 30th birthday you're celebrating, how many? It's 30 years, right? So 30 years. I think I'll put it over 1. And we want to convert that into what? Seconds. Okay. So, yeah, we got to figure that out. So let's see here. So from years, should we convert straight to seconds? What should we convert to first? What's that? Days. Okay. So for our next thing we're going to multiply by, I have to put years down here, and I will put days up here. Okay. And what's a conversion we know between what's an equivalence between days and years? What's that? Okay. Well, what I mean is like how many years is how many days kind of thing. Is how many years? 1 year. Okay? So we'll say down here, 1 year is 365 days. Why do we put years on the bottom? Well, again, we want those variables to cancel. So we're going to cancel out the label of years. And now, if I were to do this math, I would have a number of what? If I were just to multiply this out right now, I would have a number of what? A number of, what would be my label? Matt? Right now, the way I have this set up, we start with 30 years, okay? We're multiplying by 365 days per 1 year, okay, over 1 year there. If I were to multiply this out right now with the way it's written, what would my label be? Days, right? I don't have days, okay? Because that's what I don't have that canceled out yet. But we're not done yet, right? We still have to keep converting. All right, so now we're going to convert days to what? And Matt, is this what you were going to say then?
We're going to convert days into hours.
Sure, let's do days into hours. Okay, so day, 1 day, will go on the bottom there. And how many hours is in 1 day? 24, right? Now the day variables will cancel. And now if I were to multiply this out, I would be, well, if I were to multiply this out right now, what would my label be now? Hours. So this is going to be a number of hours, but we're not interested in hours. We want seconds, right? So what do I still have to do here now? Convert hours to what? Yeah, so we actually have right here 1 hour is this many seconds. So we can straight up convert, or if you wanted to, you could go from hours, then to minutes, then to seconds. But since we have this, let's go ahead and just use this. So times 1 hour in the denominator and 3,600 seconds in the numerator there. Just like that. And again, hour cancels. Okay. And now, finally, our label will be in seconds. What's our denominator going to be? Well, yeah, just 1, right? 1 times 1 times 1 times 1. And then our numerator, well, what do we have to multiply? 30 times 365 times 24 times 2,600. All right. And finally, we'll get to see if Ben did it, whoops, correctly. And he's right. 946,080,000 seconds. Okay, so 946,080,000 seconds. Old. Okay. Of course, now that we've done this, you can do it for anybody's age, So Reagan and Liv, they just had birthdays recently. They could put their number of years old they are, and then multiply by 365 times 24 times 3,600, and then get how many seconds old they are, roughly, because of course it's not quite their birthdays right now, but close enough. So you could do that if you wanted.
Mr. Wigmeyer, if we don't have the 3,600 like in the top of our head, if we're doing this without this nice little paper, then we would have done times 60 times 60.
Exactly.
Right?
Exactly. Yep, you can use minutes and seconds there if you wanted to. Yep.
It's going down minutes to seconds.
Okay. And I know, again, this might seem a little bit different than what you're used to seeing, but I really do feel like, because I can remember being in high school and learning this method too, and being like, I don't like this is too hard, I can do it by myself, I'll just do it. And you might be fine just doing it on your own, that's okay. But I will say that this method is helpful, especially when you get to the stuff on the back. It kind of helps keep your thinking organized, because sometimes we're going to be dividing and multiplying, so it can get a little, a bit much. But anyway, let's try another one here. Number 3, the first marathon in the Olympics in Athens was established by Pierre de Coubertin in 1896. Okay. He said the race should be 40,000 meters. How many miles was this race? Okay, so we want to take 40,000 meters over 1, and we want to convert that into miles. Okay, we want to convert that into miles. So, using what we have up here, we have meters, and we want to convert it into miles. So what conversion up here might be helpful for converting meters into miles? Okay, Matt, what do you say? Meters and feet? Okay. Right now we're in miles though. So we would want to convert from, oh wait, no, we're in meters, never mind. I see what you're saying. You're right. Okay, my apologies. We're in meters, we want to get to miles. Okay, let's do that. Let's try it that way. Okay, so in the denominator, I need to have meters, right? Because again, I want it to cancel. And according to this, it's 1 meter is 3.28 feet. So 1 meter, 3.28 feet. Okay, meters cancel. So now what units will my answer be in? Feet. We want to be in miles. Okay, so we need to be able to convert from feet to miles. Is there a way to convert from feet to miles here? Anyone see it?
Yeah.
Yeah?
1 mile equals, yeah, right there.
5,280 feet. Yes, exactly right, Sean. Very good. So, going back down here. Okay, feet is in the numerator, so I have to put my feet measure in the denominator here. 5,280 feet. So that way the feet measurements will cancel. And that's equal to 1 mile. Okay. So what gets multiplied in the numerator? 40,000 times 3.28 times 1 divided by 1 times 1 times 5,280. So if you want to, you can literally just type that whole mess in your calculator. Let me show you here. You can literally just type in parentheses 40,000 times 3.28 times 1. Okay, so parentheses on the numerator. Sorry, let me finish this and I'll get your question here. And then parentheses are on the denominator. 1 times 1 times 5,280. Hit enter. And there it is. 24.848484, which we could convert to a fraction if you want to, 820 33rds. I'm going to say 24.84 with a line over top. It looks like it's just going to repeat there.
No, it's not repeating because there's a 5 at the end.
I think that's a rounding. I think that's rounding, though. I see what you're saying. I see what you're saying, but I think that's rounding.
Okay.
I think the calculator just rounds it there. So, question, yeah, Sean?
Why do we have to use the parentheses?
Why do we have to put parentheses? Because anytime you're working with like fractions and stuff like that, the whole thing, you want to multiply this whole thing first and then divide by this whole quantity there like that. So we're multiplying across the top and multiplying across the bottom and then dividing those two. So parentheses are on the numerator, parentheses are on the denominator when you're doing it like that, okay? Okay. And this would be, of course, in miles. Now, does anyone know how long an official marathon is? In miles? Okay, that's half a marathon, so just double it. It would be 26.2. But yeah, 13.1 is a half marathon. Yeah, you see those stickers in the back of people's cars if you drive around, you look at them. 26.2, that's like, I did a marathon. You know.
I'll be running a 10K at some point.
Oh, nice. So yeah, 10Ks, we could use their conversions here and convert that into how many miles that is, though, if you wanted to. Yeah.
It's 6.2 something miles.
Oh, is that right?
Yes, because I used to torture myself.
With long distance running?
Yeah.
Okay, there you go. 6.2 miles.
Are you a marathon runner?
I have. I'm not currently.
Just seemed like you'd be a runner.
I do run on occasion, yes, but I don't do marathons. It's too much training.
Yeah.
It's a lot of time investment to be able to do that. So, anywho, let's do one more here. Number 4. The deepest part of the ocean is the Mariana Trench, which reaches a depth of 6,033.5 fathoms. What is the deepest part of the ocean measured in miles? Okay, so we've got 6,033.5 fathoms. And we want to convert into miles. So here, I'm going to call in some folks here now to help me out. I think we've had enough practice to maybe get some help. And if you get stuck, that's okay, though. We'll go to, of course. All right, someone we haven't heard from. Let's do that. All right, Kendall. So we want to convert here, Kendall, from fathoms into miles. So what's going to maybe be helpful here for us to convert? We have 1 fathom measure right here. So we're going to need to convert fathom into what? Feet. That's right. Okay. So times, and where should that fathom go? Should I put 1 fathom on top or 1 fathom on the bottom? Bottom, you got it. Very good. And then what does it say 1 fathom is on your paper there? 6 feet. Okay. So we can cancel out fathoms. All right. Kendall, are we done? Is that all we need to do? No. All right. pause there, though. I'm going to call on somebody else. Thank you, Kendall. Great job. Let's go to Tyler C. We got feet. We want to get it into miles.
So you get 60,000. Okay, that part. Okay, so you get that, and feet to miles is 5,280.
And I put it on the bottom, right? Because that way the feet will cancel.
Yeah.
And then what goes up here?
1 mile.
1 mile. Exactly right. So the feet will cancel. And aha, I've got to the unit that I'm looking for, miles. And so now I can just do the math. So it'll be these 3 multiplied together divided by these 3 multiplied together. So again, in your calculators, I suggest you use parentheses here when you do this. Let me show you. Okay. Parenthesis 6033.5 times 6 times 1, close parenthesis, bless you, divided by 1 times another 1 times 5,280, close parenthesis again. So about 6.86, we'll say, miles. Okay.
Hello, see you later, love.
Walk us through it.
Oh, we'll see you, Cora. I didn't eat anything, I promise. All right, so there's number 4, 6.86 miles. All right, flip over to the back. Okay, we're going to do these 3 here together as well. But this is a little bit different. We're no longer talking about single conversions. Now we're talking about rates. Okay, right? You can see here kilometers per hour versus now we're going to convert to miles per hour. Right here, meters per second and miles per hour. We're going to compare those 2 numbers. And then here, 7 pounds per year, ounces per day. Okay? So a rate, by the way, is just a comparison of 2 quantities with different units. What kind of rates do you run across in your lives? What kind of rates do you see in your lives? Yeah, Sean? That is not a rate, but yes, you may. Mm-hmm. Okay, yes? Heart rate, okay. So what would the units be for that? Do you know?
Beats per minute.
Yeah, normally beats per minute would be like the way that you measure that. Beats per minute. So how many times your heart, beats in 1 minute. And oftentimes when you go to like the doctor or something like that, the nurse will take your, will feel your pulse or whatever. They won't wait a whole minute though. They'll maybe wait 15 seconds and then multiply by 4, or 10 seconds and multiply by 6 or whatever kind of thing. So, that kind of deal. Yep, that's right. What other kind of rates do you guys run across in your daily lives? What else? I guess none of you guys are driving yet, right? So, miles per hour, that's a big one, right? You go too fast, you get pulled over. Miles per gallon, that's another important one too. What's that one about? Yeah?
Gas efficiency.
Mm-hmm. Yeah, like how far you can go on a gallon of gas, right? The higher the number, that means the less times you have to refill potentially and stuff like that too. Let's see. Well, speaking of driving too, blood alcohol content, right? So that's how many parts per whatever million, I guess, that there's alcohol in your blood and stuff like that too. And that's another important number too. For you guys, it needs to be 0. Stuff like that. Anyway, so rates are there, okay? They're all around you and stuff like that. And so sometimes we need to be able to convert, right, because they're measured different ways. For example, in number 5 here, the speed limit on the famous German road, the Autobahn, is 130 kilometers per hour, which I think that's not true. I'm pretty sure on the Autobahn you can go as fast as you want. Yeah. Sometimes they will limit it if there's like traffic and stuff like that too. They'll post signs and stuff. But anyway, it's in kilometers, which makes sense because they're German and not American, so they have the metric system there, okay? Or if you go to Canada, for example, too, you'll need to know that as well. They use kilometers per hour and stuff like that as well. Anywho, we're going to convert this speed then into miles per hour. Okay, so here's how we're going to do this. We're going to write 130 kilometers. I'm not going to put it over 1 now. Well, I'm going to put it over 1, but it's going to be over 1 what? 130 kilometers per, what goes on the bottom? Hour. So 130 kilometers per 1 hour. Okay? And we're looking for miles per hour. So, do I need to convert kilometers? If I'm looking for miles per hour, do I need to convert kilometers? Yes. Do I need to convert hours? Miles per hour, kilometers per hour. So does hours need to change? No. So we don't have to worry about that one. We'll just focus on changing kilometers to miles. Okay, so this label of hours, that can stay, but miles, we have to change kilometers to miles. Okay, so what's going to be something helpful here in our information to convert from kilometers to miles? Let's take a look here, and I'm going to go to somebody. So take a look and see. Okay. So, Shepard, what do you say there? Pass. All right. Let's go to Erica. What do you say? Do you see a conversion for miles and kilometers up here?
Is it 1 mile equals 1.615?
There it is. Exactly right. Well done. Okay. So, Erica, should my kilometers go on the bottom or on the top here? If I'm trying to cancel out the kilometers in the top here, where should kilometers go? Bottom or top? On the bottom. That's right. So we'll put kilometers there. We'll put mile up here. And it's 1.61 kilometers and 1 mile. We can cancel out the kilometers there. Boom, boom. Okay. So now the units are going to be what in the numerator? Miles. And what in the denominator? Hours. Is that what we want? There it is. So now we just multiply 130 times 1, 130 miles. 1 hour times 1.61, 1.61 hours. Well, that's kind of weird. What should we do for the final step here? Yeah, simplify. Actually do the division, right? So let's do 130 divided by 1.61. And it's approximately, I'm going to put a squiggly equals because I'm rounding here, 80.75 miles per hour. Okay. Or if you like, you could just say 80.75 miles per 1 hour, if you like it like that. Either way there.
Because that division line means many things, and one of them is per,
Right.
right?
Mm-hmm. Mm-hmm. Yep. If you guys remember back to like linear equations or lines, this is like a slope. It's a rate, a slope. Okay. All right, let's keep going here. 2 more. Maybe have you guys try. Well, okay, let's have you guys try this one. So we have 2 things here that are going really fast. We have Usain Bolt, whose maximum speed during a race is 12.38 meters per second. And then we have a cheetah that can reach speeds around 35 miles per hour. Okay? So, I'm going to have you guys pick. We want to see which one is faster. Can we tell which one is faster by comparing these 2 numbers as they're currently written? Why not? Why is it too hard?
Because seconds to hour is like big numbers.
Right, so this is in meters per second, this is in miles per hour. It's not easy to compare because they're not the same units. So you guys can pick. I either convert meters per second to miles per hour, so convert this to miles per hour, or convert this to what? Meters per second. So either convert this one to miles per hour or convert this one to meters per second. Your choice. Go ahead and give it a try. Okay, I'm going to do both in case, for those of you guys that do. But give it a try here and see what you can come up with. So either convert meters per second to miles per hours or vice versa. Okay, so I'll do that here. And if you need help, I can come around and help. I should have split it the other way, but oh well. Question time? Yes. Alex will be right there. 1 second. You have trouble with your calculator? All right. Let me just finish writing this out. I'll be right there. Just okay. So again, the idea. So which one do you want to convert? Do you want to change meters per second into miles per hour, or do you want to change miles per hour into meters per second? Okay. So I would suggest starting with one of your two variables because they're both wrong, right? That's in meters. You need miles. That's in seconds. You need hours, right? So I would suggest picking one of those two to change first. So which one do you want to tackle first? Meters to miles, or do you want to do seconds to hours? Okay, so meters to miles. Well, what can we know about a meter? What can a meter convert to be? Well, right. So miles. So right here, feet, mile. In this case, feet will go in the denominator now because we're going to cancel out with the numerator, and then 1 mile will go in the numerator. Okay, does that make sense? So multiply it. You're gonna run out of space right here, so you might want to leave yourself some space or something. Okay. All right. In the interest of time here, I'm just going to show you this one. Okay, for number 6. So there, I took that first one, I converted from meters per second to miles per hour. Okay. Now the problem with this is both meters and seconds are different than miles and hours, right? So we have to convert meters and we have to convert seconds simultaneously. Okay? How do we do that? Well, I recommend you pick one of your 2 units and convert that one, then focus on the other unit and convert that. So what do I mean by that? Here again, meters per second, I'm going to change it into miles per hour. So I chose to work with seconds and make them into hours first. So, how many seconds are in a minute? 60, right? So, 60 seconds in 1 minute. Why did I put the 60 on top? Because I had seconds in the denominator here, I need seconds in the numerator up here to cancel those out. And that was per 1 minute. Okay? Likewise, I need an hour, so then 60 minutes are 1 hour. Again, minute goes in the numerator here to cancel out a minute in the denominator, and then I'm now in hours. So I multiplied 12.38 times 60 times 60 over 1 times 1 times 1. I had 44,568, 44,568 meters per 1 hour. Okay, because I still had meters in the numerator, but I had hours in the denominator. Then I have to convert the meters into miles. So we had a conversion up in our top of our paper there. 3.28 feet is 1 meter. So again, if I had meters in the numerator, I had to have a meter in the denominator, and then 3.28 feet there in the numerator. Cancel out meters, multiply across. Okay, I'm now in feet, but I need miles. 1 mile is 5,280 feet. Again, that's from the top there. Feet can cancel, so now I'm in terms of miles, and there it is in miles per hour. Okay? So, who is faster, Usain Bolt or a cheetah? Cheetah, yeah. So even the fastest human being alive can't outrun the cheetah. Okay? How do we survive? Well, we can use tools and things like that. Cheetahs can't. Yeah. Got the opposable thumbs. Mm-hmm. Right, there you go. Yeah, that's true too. Okay? All right. We're going to do this last one here together, folks. Okay, just because I think we need the practice still. Okay? So let's take a look at this last one here. During adolescence, the average male gains weight at a rate of 7 pounds per year. So 7 lbs per 1 year. Okay? How many ounces per day does this boy grow? So we have to convert from pounds and years to ounces and days. Okay? So let's go to, so Mark, pick one here. Do you want to convert pounds into ounces first, or do you want to convert years into days first?
I would like to convert years into days.
Okay, right. So how many days are in a year? 365. Very good. So where should that 365 go? In the numerator or the denominator? Very good. And then what goes up here? 365 days is the same as 1 year. There it is. And so the years will cancel. Aha! We're in pounds per day now, but we don't want pounds per day. We want ounces per day. So let's go to Sky. Sky, do you know the conversion for pounds and ounces?
It's 16.
Yes, it is. Very good. So, since I have pounds in the numerator over here, where should the pounds go over here? Numerator or denominator? Sorry? Very good. So 1 pound is, you said 16 ounces, right?
Yeah.
So there the pounds cancel. 7 times 1 times 16, 112 ounces over 1 times 365 times 1, so just 365, and that's days. Okay. But of course, what should we do from this point? Divide. Actually do the division, simplify. So 112 divided by 365, and we get 0.31, I'll say, I'm rounding, ounces per day. Okay? So you all are all you folks are in adolescence right now. Okay, if you're an average male, then about every day you're gaining 0.31 ounces per day. But of course, you guys have things like growth spurts and stuff like that don't really happen on average like this. They kind of happen suddenly, maybe. But at least on average, you're gaining about 0.31 ounces per day. Okay. Questions on any of that? All right. That was pretty intense, guys. I'm sorry about that. I didn't realize it was going to be, but I guess that makes sense because this is really tricky. There is homework. I'm going to give it to you here real quick. Okay, I know.